Welcome to the chapter on indexes. In this chapter, we're going to cover some of the different indexes supported by MongoDB, and we'll also discuss the different properties that those indexes have. In this first video, we're going to examine what indexes are and how they work. And to answer this first question, I think it's helpful to ask the question, what problem do indexes try to solve? And that is slow queries. Let's use a quick analogy to illustrate what I'm talking about. Let's say we're looking for some content on bedspreads in a book about interior design. One way that I could find this information is I went through the book page by page, looking for information on bedspreads. But this would not be very fast. I could find this information much more quickly if I went to the back of the book to the index, where I can quickly search for the word bedspread because the index is ordered alphabetically. I'll then find what page talks about bedspreads, and I can go directly to that page. And this is essentially how database indexes work. Working off the book analogy, a book, in the context of MongoDB, would be a collection. If we don't use an index when we query our collection, then the database will have to look at every single document. Creatively, we call this a collection scan, which means as our collection grows in size, we'll have to search through more and more documents to satisfy our query. In computer science, we call this an order of n operation, commonly referred to as big O of n, or having a linear running time. And that's because the running time of our query is linearly proportional to the number of documents, n, that we have in our collection. But we can do much better if we have an index. Like in the book analogy, we can use an index to limit our search space. Rather than searching through every document, we can search through the ordered index first. The MongoDB index keeps a reference to every document in our collection. Think of this index as a list of key value pairs, where the key is the value of the field that we've indexed on, and the value of the key is the actual document itself. I like to point out that this means that an index is associated with one or more fields. This means when we create our index, we have to specify which fields on the documents in our collection we want to index on. For example, the _ID field is automatically indexed for us. But if I were to write a query that didn't use the _ID field, I wouldn't be able to search the _ID index and find the reference to my documents. And it is possible to have many indexes on the same collection. I might create multiple indexes on different fields if I find that I have different queries for different fields. Like the index at the back of a book, the index keys are stored in an order. Because of this, we don't have to look at every single index entry in order to find it. MongoDB uses a data structure called a B-tree to store its indexes. B-trees can be used to find target values with very few comparisons. With a collection scan, each new insertion creates an extra comparison. But with a B-tree, each new insertion doesn't necessarily mean an extra comparison. For example, if I was searching for the value of 15, my search wouldn't change if I inserted the value of 5. We can plot a chart to get an idea of how many fewer documents we need to examine when using an index. You can see that when we don't have an index, we have a very linear function of number of comparisons. But when we do have an index, we need to examine far fewer documents. Before I finish this video, I would like to discuss one last topic, which is index overhead. The awesome query performance gain that we get with indexes doesn't come for free. With each additional index, we decrease our write speed for a collection. Every time there's a new document inserted into a collection's indexes might need to be updated. Similarly, if a document were to change, or if it was completely removed, one or more of our B-trees might need to be balanced. This means that we need to be careful when creating indexes. We don't want to have too many unnecessary indexes in a collection, because there would then be an unnecessary loss in insert, update, and delete performance. You should now have a good idea of what indexes are, their pros and cons, and how they work.